Hey everyone, this is Scott Redmond from RedmondPhysicsTutoring.com, and in this video I'm going to go through a very tricky example of calculating the equivalent resistance between 2 points in a circuit. The key idea is to divide and conquer, so I'm going to use colors the way I did in a different video to identify the parallel and series elements, and then I'm going to work with a small group at a time until I can come up with one equivalent resistance for the whole thing. So I'm going to start by coloring it in. I'll have a red wire going up from the EMF, and I'm coloring in until I reach each element. Dark blue wire, light blue wire, green wire, and yellow, and everything is connected. So then the yellow wire is connected only to R1 and R2, so those are in series, and we can add them up. I'm going to really quickly give R1 is 1 ohm, R2 is 2 ohms, R3 is 3 ohms, 4 ohms, 5 ohms, 6 ohms, and 7 ohms, so all the resistors have values that we're going to use for the math. So then to find the equivalent resistance for 1 and 2, we're going to add those two, and we get the equivalent resistance, or R12, is equal to 1 plus 2 ohms gives 3 ohms. And then we can actually replace those two resistors with a single equivalent resistor, R12. Then I'm going to look at the top right. We have the red wire connecting R3, R4, and R6, and the blue wire connecting all those same elements, so those three resistors are in parallel, and we can add them up. The rule for adding resistors in parallel is a little trickier than in series, but it's really not so bad, and I'm going to just show you how I do it on my calculator. So my calculator, scientific calculator, not terribly expensive, but it has brackets and it has this inverse button labeled 1 over x for me, but it might be x to the power of -1 for other people. On my calculator then, to calculate this, I'm just going to do open bracket 3 inverse plus 4 inverse plus 6 inverse, and then invert the whole thing, and that gives me the answer. And the final solution here is 1.3333 ohms. So the equivalent resistance for R3, R4, and R6 in parallel is 1.333 ohms. I can then replace that group of 3 with a single equivalent resistor that has that resistance that we just calculated. Now that equivalent resistor has red on one side, dark blue on the other, and that dark blue wire connects only that equivalent, R3, 4, 6, and R7. And there's a light blue wire that connects only R7 and R5. So those three resistors now, on the right, are in series, and we can add them up directly to get 13.333 ohms. Now we're left, and we can simplify again, with a circuit that has the EMF and then two other resistors connected, red on one side, green on the other. They're in parallel, so we can add these up in parallel. We have open bracket 3 inverse plus 13.33333 inverse close bracket inverse to get the total resistance. Then we get the equivalent resistance of all 7 resistors to be 2.45 ohms. Thank you so much for watching. I really hope that this can help you. If it does, please let me know by leaving a comment. And if there's a topic that you would like me to go into, head over to RedmondPhysicsTutoring.com and go to the contact page and let me know. Good luck!